Hello everybody, I would like to welcome you to our 14th video in the pre-algebra playlist, and in this video we are going to go over solving equations through the means of addition and subtraction. Now before I begin, I would just like to say one thing when it comes to solving equations. Whatever you do to one side of the equation, you need to do the same exact thing to the other side of the equation. I'm going to go over the meaning of this sentence later on in the video when we get to the solving part of the equations, but one of the best ways to remember this is to remember the saying, don't hate, imitate. Now that might be a very juvenile way, but that always reminds me that whatever I do to one side of the equation, I always need to do the same thing to the other side of the equation as well. So now before we get to the steps that are involved when you solve equations, let me go over two things. And these two things are what are known as the addition property of equality and the subtraction property of equality. This terminology of the addition property of equality may sound really intimidating and all, but it really is quite simple. It basically tells me that if I have two numbers represented by the variable a and b, and I have another number represented by the variable c, then if a is equal to b, then a plus c is equal to b plus c. So in this case, a and b are the same exact number, and c is another number. So if I add c to a and I add c to b, I will get the same number on both sides. An example of this is, let's say that a is equal to 5. And since a is equal to b, that tells me that b is also equal to 5 because a and b are the same number. So I start off with the following: 5 equals 5. Now let's say I add some number c to both sides. Now in this case I can have c be any number, but let's just say for the purposes of this statement that c is equal to 3. So if c is equal to 3, then I have a plus c being 5 plus 3 equals b plus c, which is the same thing as saying 5 plus 3. And since 5 plus 3 is 8, and 5 plus 3 again is 8, I get my true equation over here. Now the subtraction property of equality is very similar to the addition property of equality. Again, I have two numbers being equal to each other. So in this case, I'll use the variables d, e, and f. So if d is one number and e is another number, and they're both the same numbers, I have d is equal to e. Then d minus f is the same thing as saying e minus f, given that f is the same number on both sides of the equation. So an example of this can be seen over here. If I have d equaling to some number, in this case let's say the number is 4, and e is also equal to 4, then the statement d is equal to e holds true. Now if I say f is equal to some number, and in this case let's say f is equal to 3, then I can rewrite this sentence over here, d minus f equals e minus f, like this over here. And since 4 minus 3 equals 4 minus 3 is the same thing as saying 1 is equal to 1, this is a true equation right over here. Now if you're wondering why I just showed you these two properties that seem rather obvious, you'll understand why later on in this video. Now before moving on to the steps that are involved in solving equations, let me go over one more thing. And that thing is what is known as the inverse operation. So what is meant by inverse operation and how does it relate to what we have learned so far? So let's say you have something such as 3 plus 6 equals 9. In this case, this is a true equation because 3 plus 6 is equal to 9 and 9 is equal to 9. Now, what I can do is that if I want to get 3 all by itself, or basically if I want to isolate 3 on the left-hand side of this equation, all I really need to do is find some way of moving this term plus 6 onto the other side of the equation. Now, I can't really just add 6 over here and then just say that I'm done, because that doesn't work, because I haven't performed the proper inverse operation. In order to get rid of plus 6, I really need to add negative 6 to both sides. Now what I mean by this is that using the subtraction property of equality, I can rewrite 3 plus 6 equals 9 in a different color like this over here. I can rewrite this as 3 plus 6 minus 6 equals 9 minus 6. All I really did was that I added the term negative 6 onto both sides of the equation. Now, what purpose does this serve, and how will that help me isolate the 3? Well, if I simplify the left-hand side of the equation again, then I get 3 plus 6 minus 6. And since plus 6 and minus 6 are opposites of each other, that is the same thing as saying 6 minus 6, which will give me a 0. So I'm essentially saying 3 plus 0 equals 9 minus 6. And since I don't really need to write the plus 0, I can simply write 3 equals 9 minus 6. And so there I have simply isolated the number 3, which I wanted to do in the beginning, over here. And the way I went about it is that I performed the appropriate inverse operation. So now that you know what an inverse operation is and how that helps you isolate terms or things or numbers on one side of the equation, let's go over 4 steps that are involved in solving any equation. So on this page, I'm simply going to write down the 4 steps that are involved in solving most equations out there. And if you don't really get them right now, please hold on until the examples portion of this video when they will be cleared up easily. So the first step in solving an equation, and remember that once you get really comfortable with solving equations, you can actually reorder these steps to best fit your abilities. But the way I remember it is the first thing that I do is that I get all the variable terms on one side of the equation by performing appropriate inverse operations. The second step that you do is that you get all the non-variable terms, or basically all the numerical terms, on the other side of the equation by performing appropriate inverse operations. Now in the third step, you need to combine all the variable terms, if you have more than one variable term on one side of the equation, so that you're left with only a single variable term. And you need to do the same thing by combining all the numerical terms with each other in a way that you're left with only one numerical term on the other side of the equation. Now this fourth step will not be used in solving equations part 1 video, but we will use this in the next video. But it basically tells you that you need to perform appropriate inverse operations so that your variable term has a coefficient of 1 on it. Now, if I have thoroughly confused you so far, I hope that your confusion will be undone itself when we go over a few examples. So in this first example, let's say I have the equation x plus 8 is equal to 6. Now the first thing that I need to do is get all the variables on one side of the equation. This is already done for me because I only have one variable and it is on one side of the equation. The next thing that I need to do is perform appropriate inverse operations so that all my numerical terms are on the other side of the equation. So basically what you need to do is find some way of moving the term plus 8 onto the other side of the equation without breaking the rules of mathematics. And in order to get rid of the term positive 8, I need to find an appropriate inverse operation that will yield a 0 right next to the x, so that the x is isolated all by itself. Now, if I perform the inverse operation of negative 8 on both sides of the equation, I can rewrite x plus 8 equals 6 like this over here. In this case, I haven't changed my answer, or I haven't really changed my equation, because I have simply applied the subtraction property of equality. If I subtract the same number from both sides of the equation, my equation still remains equal. So, if I simplify the left-hand side of my equation, I have x plus 8 minus 8. And 8 minus 8 will give me a number 0. So this is the same thing as saying x plus 0 equals 6 minus 8. I can rewrite x plus 0 by simply writing x equals 6 minus 8. And then finally, to get my answer, I can evaluate the right-hand side of my equation, which is 6 minus 8, to give me a negative 2. And so, the solution to my equation, x plus 8 equals 6, is x equals -2. Now let's just check it out real quickly. If it's a solution, I need to plug in -2 in for x, and when I do that, I need to get a true equation. So -2 plus 8 is equal to 6. And since 6 is equal to 6, I get a true equation over here, and therefore -2 is a solution, or the answer, of x plus 8 equals 6. Now let's do another example. Let's say you had the equation 7 equals a plus 3. So first you need to get all the variables on one side of the equation, which is already done. Next, you need to get all the numerical terms on the other side of the equation. So I really need to perform an appropriate inverse operation so that this plus 3 term over here can be safely moved to the left-hand side of the equation without changing my equality. Now I can refer back to the subtraction property of equality and realize that the appropriate inverse operation that I need to perform is that of -3. So I can rewrite this equation over here like this over here. Since I did the same thing to both sides of the equation, I haven't changed my equality. Therefore, I can now simplify the right-hand side to get my variable a all by itself. So a plus 0 on my right-hand side and 7 minus 3 on my left-hand side. I can rewrite a plus 0 as simply a and 7 minus 3 as the number 4. So 4 equals a is the same thing as saying a is equal to 4. It's the solution to my question. So let's just check it to be doubly sure. So if I have 7 equals a plus 3, where a is replaced by the number 4, then I have 7 is equal to 4 plus 3. And since you know that 7 is indeed 4 plus 3, this is a true equation over here, and so the solution is indeed a is equal to 4. Let's say in this example you have b minus 8 equals 11, and all you really need to do is find a way to bring this -8 term onto the other side of the equation without changing the equality. I can refer back to the inverse operation and the addition property of equality to realize that the term that I need to add to both sides of the equation is positive 8. Now when I simplify -8 plus 8, I get a 0, which is what I'm looking for. And I get b minus 0 on the left-hand side and 11 plus 8 on my right-hand side. So my solution to the equation b minus 8 equals 11 is b equals 19. So if I replace 19 for the variable b, I get 19 minus 8 equals 11. And since 19 minus 8 is indeed equal to 11, and 11 is equal to 11, I have a true equation over here. So b equals 19 is the solution that I'm looking for. Now let's solve two word problems that are rather easy, and then we'll be done for this video. Now in this example, we have if Sarah drove 38 miles on Wednesday, which is 16 more miles than she drove on Tuesday, how many miles did she drive on Tuesday? Now in this problem, what we're trying to find is miles driven by Sarah on Tuesday. We can represent that by the variable t. We know that Sarah drove 38 miles on Wednesday. We also know that that is, which means an equal sign, 16 more miles than she drove on Tuesday. So our equation is simply 38 equals 16 plus t, and we are trying to solve for the variable t. So all we really need to do is perform the appropriate inverse operation to get rid of the plus 16 over here. So the inverse operation that we are trying to perform is that of minus 16. Now on my right hand side of the equation, I have plus 16 over here and I have minus 16 over here. So plus 16 and minus 16 will combine to give me a grand total of 0. So I have 38 minus 16 on my left hand side and simply a t on my right hand side. So we know that the solution to this equation is 22. So in this example over here, we have that if Erin's laptop costs $68 less than her tablet, and her laptop costs $158, how much does her tablet cost? What we are trying to find is the cost of her tablet, which we will denote by the variable t. And what we can do is that we can denote the cost of her laptop by the variable L. So we can write an equation describing the relationship between the cost of the tablet and cost of the laptop by writing the following over here. By writing L equals T minus 68, I'm saying that the cost of the laptop is, which is an equal sign, $68 less than the cost of the tablet. But what happens now is that our life is simplified further because the problem gives us the cost of Aaron's laptop. So we can simply replace the variable L by the number 158. Now, in order to get the variable t all by itself, we need to perform the appropriate inverse operation with the term negative 68. The inverse operation of negative 68 is plus 68. Now, negative 68 plus 68 will give me a grand total of 0, and I'm simply left with the variable t. And I know that 158 plus 68 is equal to 226. So the cost of Aaron's tablet is $226. So I hope you learned a lot from this video, and I hope you keep on working hard, and I'll see you in the next video.